Now we're actually going to start doing some translations and transformations with the graph of sine and the graph of cosine. So here we have written the 4 places that we can put numbers in to change our graph. So we can write it as a times cosine of bx plus c plus d, and the same thing with sine. Now let's go through what each of those 4 numbers do, if we put them in for a, b, c, or d. So a, if we're multiplying out on the outside, remember that's going to be a vertical stretch or shrink. Okay, when it's a number bigger than 1, it's going to be a stretch. When it's a number less than 1, it's a shrink. Now that's going to change the amplitude. So the amplitude is actually the absolute value of the number that's out in front of the sine or the cosine. Okay, the b inside times the x, the number times the x, that's going to be a horizontal stretch or shrink. Remember, that's kind of backwards. When it's a fraction, it's actually a stretch. It's going to make it longer. When it's a number bigger than 1, it's going to shrink it. And what this changes is our period, kind of how fast you get through that first wave, or any of the waves. And so to find what the period is, you're going to take 2 pi divided by that b value. Okay, next we could add or subtract a number inside the parentheses. So that's the c, and that's going to be a horizontal, that's going to move it left or right. So a horizontal translation. And remember, it's left if it's positive and right if it's negative. Okay, and then adding the d to the end, that's our vertical translation. That's going to move it up or down. Okay, so we've talked about the period and the amplitude. If we want to look at the total phase shift, how we've moved left or right, we're actually going to take negative c over b. Okay, and if it's positive, that will actually be going to the right, and if it's negative, you'll be going to the left. And the vertical shift is just what d is. Okay, so we're going to look at a few examples. So here we have f of x equals 2 plus 4 sine of x. And if you want to write this kind of in the same order as above, this would be 4 times sine of x plus 2. Okay, so here if we list out what our a, b, c, and d are, so our a, the number out in front, is 4. So that tells us that our amplitude, this has gone up by 4. Our graph will actually go up to 4 and down to negative 4 if we haven't done anything else. Okay, now the number we're multiplying in x, think of this like a 1x. So our b is 1, which actually means we haven't changed our period. If we just took 2 pi over 1, we would just get 2 pi. Now, we haven't added in anything inside the x, so our c is 0. That makes our phase shift 0. And our d on the outside is 2, so we've gone up 2. Now, with the vertical shift and our amplitude change, our range has actually changed. And remember, for sine and cosine, our range always starts out from negative 1 to 1. Now, to see how the amplitude and the vertical shifts have changed it, you're going to take both those numbers and multiply them by the new amplitude. So that would make this from negative 4 to 4. But not only have we stretched it, we've also moved it up. So then you have to add your vertical shift to both the numbers. So that will make it negative 2 to 6. So you can always do those two things, multiply by the amplitude and then add your vertical shift to get your new range. Okay, so the lowest our graph will be negative 2, and the highest it'll go is 6. So here's we're going to graph it. Let's make each of these dots 2. So this would be negative 2, negative -4, -6, 2, 4, 6. So we'll see our graph is going to be between these two values. Now, we really want to make sure we at least graph one period. So normally sine starts at 0, 0, but we've shifted that up 2, so it'll now be at 0, 2. You'd multiply that number by 4 and add 2, so 0 times 4 is 0 plus 2. Then at pi over 2, it's normally at 1. Well, if we multiply 1 by 4, we get 4, and add 2, we get 6. Then at pi, it's back at 0, which 0 times 4 is 0 plus 2 is 2. Then it goes down to -1 at 3 pi over 2. So if we take -1 times 4, we'd get -4, and we add 2, we get -2. And then at 2 pi, it's normally back at 0, which we've seen will be where it's at 2. So this would keep going in, both directions, but at least here you can get an idea if you just graph at least one period of what this new graph looks like. Okay, we're going to do one more. So here we'll do one with cosine. So here we've got 2 cosine of 4x plus pi minus 3. So let's write out what our A, B, C, and our D are. Okay, so our A is 2, our B is 4, our C is pi, and our D is -3. So from the A, we can tell our amplitude. Our amplitude is 2. The other one that's really easy is our vertical shift. Our vertical shift is what we're adding or subtracting from the end, so that's our -3. Now remember, the formula for period was 2 pi over b. So our new period is going to be 2 pi over 4, which we can reduce to pi over 2. That means our whole wave for sine is going to happen in just pi over 2. Okay, in our phase shift, we take -c, so -c, which is pi, so -pi over b over 4. So we're shifting to the left by pi over 4. Okay, so if we want to think pi over 4 would be halfway. Where we would normally start at 0, we can now start at -pi over 4. Okay, the range. Remember, we always start with -1 or 1. We're going to multiply that by our amplitude, which is 2. So that would go from -2 to 2. And then we're going to add our vertical shift, which here is subtracting 3. So we're going to go from -5 to -1. So if we make these by 2's again, so that'd be -2, -4, -6. So our graph is going to be in between these dotted lines. And since our period's so small, it's going to be a very kind of shrunk version of cosine. So if you think about where cosine normally starts, it normally starts at 0, 1. Well, that point, which would be 0, 1, is now going to be over at -pi over 4. Okay, and if we multiply the 1 by our amplitude 2, we'd get 2, and then we subtract 3, we would be at -1. So where we'd normally be at 0, 1, we're going to be at -pi over 4, -1. Now, we only have pi over 2, so half a pi, to get our whole graph in. So from -pi over 4 to pi over 4, that's where a whole graph will come in. So if we think about what happens next, halfway, a quarter of the way in, we go down to 0. Well, our new 0 is going to be at -3, so like here. Okay, then we go down another quarter of the way. We go down to our lowest point, which would be -1, which now here, since we've moved down, will be -5. Then we go back to our middle point, which we said is -3, and then we go back up to our highest point. So this would be one period of cosine where we've translated it, and it would keep going on kind of very smushed like this, and in between those values as a wave in both directions.